Welcome back. We're going to begin our work on Unit 7, and we're going to change our focus in terms of our interest formulas from what we saw previously in Unit 6, which was simple interest, to the notion of compound interest, and wherein instead of just having a flat principal for the whole length of time, we're going to bust up that time span into a number of interval units, and we'll find that we will add the interest and then find interest on the original principal plus the interest that's already been added in. It sounds intense. It is. Lovely formulas to use. We'll take a look at a hardcore example just to make you appreciate the formula. And with no further ado, let's go get this thing and run. Slideshow from beginning. All right, in first compound, we're looking at future values, present values. Future simply means how much is it worth right now. Present value means how much it will be worth at some point in the future. Content found from chapter 19 in your textbook. There are considerable issues for us to look at. We'll be looking at section 19.1, where we will introduce the notion of compound interest, and then we'll examine how it relates to present value in 19.2. And I got some interesting things that I want to throw in to allow us to answer the how long kind of questions until this money is worth this much. And that's going to use some logarithms that we may have to look at a little bit more directly. So that's our overview. Objectives, again, I will try really hard not to read them to you. You'll be able to find them as we relate to this information in this unit. 19.2, and there's the extra section by yours truly with logarithms to help us answer questions like how long. Okay, some words for us to consider. The notion of compounding means we're earning interest on principal invested plus interest earned previous to this point in time. It's generally to our advantage to have compounded interest rather than simple interest. Future value amounts to how much is it worth at some point in time in the future at the end of its last compounding period. Present value means what's it worth right now. Previously, we've been using present value as P. What was the principal that started this whole particular investment thing, whether it be a loan or whether it be money that we've invested and somebody's paying our interest for the use of our cash. Words from yours truly. Your author likes this chart stuff, and I don't like it even a little bit. We're going to get formulas out and active. We're going to grab a calculator and just have to use some calculator skills. If calculator issues are bemoaning for you, you need to send me an email. We'll grab some time. We'll fire up some kind of a team meeting, and you and I figure out punch sequences for your specific calculator. It does seem like in my experiences, a lot of folks use Texas Instruments. So most of what I've done here probably relates to a TI. If you're running a Casio or an off-brand, shoot me an email. We'll figure out what kind of sequencing is necessary for you. Okay, section 19.1. We're going to roll because there are quite a few slides and I don't want to exceed my 15-minute time limit on my video. So I'll let you read and we'll play. If you're compounding annually, that means one time a year they're adding interest. If you're compounding semi-annually, every 6 months they'll add interest in, and then they'll calculate a new interest amount based on what you started with, plus that first addition of interest. So compounding twice a year, quarterly 4 shots a year, monthly 12, weekly 52, daily 365 if you're going exact. And in this section, I don't think we're going to see a lot of daily stuff coming in. You will see quarterly, you'll see monthly. Okay, you might even check out a semi-annually here. I think there are a few annual. In fact, I think the first couple of examples are probably just once a year. All right, a slide for you to read. We've already looked at simple, where it's a one-shot deal. At the end of a certain period of time, interest gets added in. On compound interest, that's not the case. Right? The principal or present value earns interest for the first investment period, then that interest gets added in, and then a new principal is created, and further on, interest is calculated on that new principal. It's not difficult to do. It is tedious to do. We're going to do one in a tedious fashion so you can see how it all plays out, and then we'll introduce the formula as we get to our second video for Unit 7. All right, here we go. So here's your example. Frank's going to deposit $800. He's going to let it sit for 4 years. All right. And the interest rate is 8%. and we're compounding annually. Okay, so he's going to let that thing sit for a year, then they're going to add interest. Then he's going to let it sit for a second year, and they'll add interest on his initial $800 plus what he earned in the first year. So let's tear it apart and let's look at it. Formula, it looks familiar from last time, and the beginnings are really no different. So for that first year of interest, Frank gets 8% for 4 years, and this is a simple interest run. So at the end of 4 years, he would get added in $256. All right, so this one is not compounding at all. This is a simple interest shot. So that's an old friend from Unit 6. And at the end of the 4 years, Frank would get added $256, and his 800 would now be worth $1,056. Okay, so I'm sorry if I got you confused there. I didn't mean to. We're comparing simple, which we've done previously, to what we'll look at in this unit, which is the notion of compound. Now let's go compound. All right. So what's going to happen in this context is that 800 starts only for the first year. So let's look at how he plays. So interest just for year one, $800 at 8% for 1 year. $64 gets added in. So his principal now changes. And at the end of that first year, his principal becomes the amount he's got invested now is the original 800 plus the 64, or $864. So as we move into year two of his 4-year investment opportunity, what we're going to see is the principal changes. So it used to be 800, but not after year one. It's no longer 800. We're compounding on that 864. So the interest for year two, again, notice the time is only 1 year. It's year two. 864 is his new principal at 8%. He's going to earn $69.12. Well, his previous balance was 864. So now his investment gets added to that 864 to 69.12. So his investment opportunity headed into year three is for a balance of $933.12. Let's go get it. All right. That's his principal to start the third year. Same formula. Notice his principal now updates to $933.12. Still 8%. Again, one referencing year three, 1 year of his investment opportunities. So each year, interest is being added in from my man Frank, and it's increasing his principal as we go from year to year. This time it's going to increase his principal by $74.65. So we'll take the $933.12, we'll add the $74.65. So my man Frank now up to $1,007.77. Got one more year to roll because we're trying to find out how much he'll have after 4 years. So let's go get it. That's his new principal headed into year number 4. Fourth and final year for Frank. Here's his new principal, $1,007.77, still 8%. 1 year. This is 1 year, year 4 of this investment opportunity. So on that year, Frank's going to earn $80.62 interest. So his initial balance to start that year was the $1,007.77. And if we add his $80.62, at the end of Frank's 4th year, he now has $1,088.39. So it's not hard to do. Honestly, if you had to do this for 27 years, I think I'd lose interest and want to go play ping pong or something, maybe read a book or eat some Doritos. But I thought for 4 years, it's not too bad. We can certainly take a look at the notion of compounding. All right, if you want to compare the two, here's some numbers in simple interest. All right, the $800 at the end of 4 years amounted to $1,056, and he earned $256. On our compound attack, his 800 to start generated $1,088.39, and he earned in interest $288.39. So you see the difference is interest being earned not just on the original 800, but on the interest as it got added in year by year. Words from me. You kind of already heard this sentiment. I like it. I like to calculate. It's kind of a fun operation. But if you had to do this for a ton of interest compoundings per year or for a span of more than 4 years, I think it would get tedious. So we're going to rely on the formula to take care of the heavy lifting. That ends video 1. I'll be back soon with video 2 for Unit 7. See you then.